Okay, so in this video, we are going to look at some worked examples of Pythagorean Theorem word problems. A few quick reminders on that. So the first thing, recall that if I have a right triangle with legs A and B and hypotenuse C, the Pythagorean theorem tells me that a squared plus b squared equals c squared. And for the word problems, I am going to only get decimal answers. I'm not going to reduce the radicals for any of my word problems because in most real-world situations, saying that something needs to be 23.7 inches wide is much more useful than saying something about like the square root of, I don't know, it's going to be close to 563. Something, I don't know, something weird. So the decimal is going to be much more useful. The most important part for the word problems is make sure that you understand the situation. I can't stress that enough. You can oftentimes get an answer or get an approximation if you just read carefully enough and say, what's going on? What's going on? Spend most of your time, most of your struggle, making sure you understand. If you get there, the actual computation, the mathematics afterwards, is easy. So let's dive right in. I have 4 example problems to get a feel for this. Here's our first one. You're flying a kite. You know that you have let out 150 feet of string. You think it would be really cool if your friend standing on the roof of his house can catch the kite that you are flying. If your friend is currently 25 feet above the ground, how far back should you stand so that your friend can catch the kite? So I gave you the diagram. Again, that may not be there. This is the most likely diagram I've seen for Pythagorean theorem word problems showing up in something like the SAT or in general, but it's not the only one. And so I just need to figure this out. So it's probably a bad idea to have a kid on a roof and another kid flying a kite at the roof, but you know, whatever, gotta have some fun. Hold on, I guess I should put this down here. Do not try at home. I don't want to hear of anyone falling off of a roof because they saw this nifty math problem and really wanted to try it. So don't try this at home. Okay, so let's label up our diagram. I've let out 150 feet of string. Let's figure out what's happening. So you are here. Apparently you're blue. Your friend, let's make your friend purple, is up here on top of his house. Okay, your kite, you want the kite, I'll make the kite yellow, to be caught by your friend up here. So let's label up this diagram. I know that I've let out 150 feet of string. So that means that this length here is 150 feet. My friend is 25 feet above the ground, so I'll make this 25 feet. I want to know how far back I should stand, so here's the house. I want to figure out how long this distance is. Now, I know you're probably not holding the string from the ground. Your friend can catch from various heights. So I'm going to just solve this off as if these are exact numbers, but in a real calculation, if I wanted to be more careful, I might deal with the distance between this and the ground, the fact that your friend can catch something from higher up or possibly lower down. So there's more to this problem, but I'm going to keep it simple like this. All right, start off with Pythagorean theorem the same way as before. So I go across from the right angle, and my 150 is going to be C, so I'll have 150 squared by itself. A and B does not matter, so I will have 25 squared plus x squared, and then I'll just do the computation. So 25 squared, I already know that, but let's just pretend that I didn't. 25 squared is 625 plus x squared, and 150 squared, I can do that knowing what 15 squared is, but let's just say I didn't know that, and I get 22,500. Now I will subtract 625 from both sides. And let's see what I get. I get 21,875. And to finish it off, I take the square root of both sides. I don't need to break this down. Let's just go to the calculator and get a decimal. Take the square root. And so it looks like I should be 147.902. So x is approximately 147.902 feet. And again, in the real world, I would probably just round it off to 148 feet. It really depends on the context of the problem, and there's a lot of uncertainty in this. All right, next example. Now you're flying in an airplane. When you look out of the window, you see the Eiffel Tower. You know from your GPS that you are 10,000 feet horizontally from the tower, and you know that from your altimeter that you are currently 5,000 feet above the ground. How far are you from the Eiffel Tower? And again, I'm considering that you are a point, the Eiffel Tower is a point. There's lots of stuff here, but let's not get caught up in the nitty-gritty, and let's just go ahead and figure this out. So, you are in a plane. That means you're up above the ground. So you are, there's my plane. All right. The Eiffel Tower, it's on the ground, okay? Spoiler alert, if you haven't seen it yet, it's not floating in midair. So the Eiffel Tower, I'm not quite sure how the top looks. We'll just do that. There we go. Get a little bit of stuff there. And yeah, there we go. Eiffel Tower. Lovely. Okay. And I need to label some things. So, in here, I know for my GPS that I am 10,000 horizontal feet from the tower. So I'll put 10,000 feet here. I know for my altimeter that I'm 5,000 feet above the ground. So that's how high up and down I am. So 5,000 feet. And I want to know how far I am. Well, how far I am is the distance from me in my airplane to the tower. So that's the unknown, that's my x. And I just go through and set this up. So go across from the right angle and see that x is the hypotenuse, so I have an x squared there. I have a and b as 10,000 and 5,000, so I'll do 10,000 squared plus 5,000 squared. I'll go to my calculator. Again, they're not hard to square those numbers, but just to be safe, 10,000 squared gives me, let's see, that's going to be 100 million. 100 million. 5,000 squared should give me 25 million, but let's just check. 5,000 squared gives me 25 million. That's going to be x squared. I add them, so 100 million plus 25 million is 125 million. And the final thing to do here is to get rid of the squared by taking some square roots. And so let me add on 100 million and take its square root, and I get about 11,180. So 11,180 .3398. Now, in this case, it's a fun little rounding thing. If I round this up, the 9 rounds up to sort of 10, so it should be 0.340. And that's going to be measured in feet. And again, in this situation, I would probably round it far more, but I'll just treat these as if they were exact answers. Okay, here's another one. You're currently bored at baseball practice because, I don't know, it's baseball practice. So you decide you'll have some fun with math because math is always fun. You want to figure out how much shorter it is to run straight from second base to home plate, running the diagonal, as opposed to running from second base to first base, then to home plate. If a baseball diamond is a square with 90-foot long sides, how much shorter is it to run the diagonal? So this one actually involves a couple of steps. As with all of our examples before, I'll first realize that, okay, if I run a diagonal of a rectangle, or in this case a square, I get a right triangle over here. So I know that this is 90 here, this is 90 here. I want to find this length here. Now I do the Pythagorean Theorem. So across from my right angle is x. That means x is my hypotenuse, and I'll have an x squared by itself. The other ones I'll have 90 squared for a squared and 90 squared for b squared. I'll go to my calculator, figure out what 90 squared is, just in case you can't do that in your head, and get 8,100. And then I'll add those two together. And yes, I could have multiplied by 2 as well. Same thing. Get 16,200. And since I don't care about the decimal, I'll just go to the calculator to take the square root. And the square root of that is 127.279. So 127.279 feet. Okay, but in this case, I didn't want to know just this distance. I want to know how much shorter it is. So if I think that I'm standing over here and run this distance and this distance, assuming I make a right angle turn there. Of course, there's lots of other assumptions that can be made, but we'll sort of do the simplest possible computation. I know that the original distance is going to be 90 to go from second to first, plus 90 more to go from first to home, which is 180 feet. I also know that if I just ran straight across the diagonal, then that would be 127.279 feet. So to find how much shorter this is, just subtract 180 minus 127.279. So 180 minus 127.279. And I get that it is 52.721 feet shorter. So that one involved more work after the right triangle. Okay, last one. You want to build a wooden door that has one diagonal cross brace. You want the door to be 2.5 feet wide and 7 feet tall. How long should you cut the cross brace? So this is another very realistic problem. If you don't know, if you had a rectangular frame, and it's just a rectangle, and you put a little bit of side force on it, this rectangle can tend to very easily collapse. So if I don't have any type of support, it can fall apart and these pieces here can break. And so that's why if you see a bridge, or if you see the framing for a large building, they will oftentimes put some type of trusses, crosses, triangles in there. Now, for the walls in your house, the studs, the joists are probably rectangles, but those actually get even more support. So if you have the rectangle and then you screw on a piece of wood, it actually gets supports going across because of that piece of plywood or sheeting that's on there. So, but for my door, let me get rid of all this stuff. For my door, if it's just this frame, it's very possible that it does not have appropriate support as is, so I'm going to put this cross brace in. That's a lot of talking to just basically do a simple problem, so I'll do the simple problem now. We know it's 2.5 feet wide. That's width, 2.5 feet. I know it's 7 feet tall. Hey, there's your height. There's 7 feet. I know that if I go for the diagonal of a rectangle, I better have a rectangular door. If it's not rectangular, it's probably not going to fit in my house. So that means I will have a right triangle here. I'm trying to find this length, which is my unknown, because it's my cross brace. And so, just do a little Pythagorean theorem. A cross in the right angle, that's x, so that will be c. A and b can be 2.5 squared plus 7 squared. I'll go to the calculator. 2.5 squared is 6.25. 7 squared I already know is 49. I'll add those together and get 55.25. And the last thing, to get x by itself, I'll take a little square root. And so, 7.433 feet. So, when I go to my table saw or my, I might not use a table saw, I might actually use a miter saw for this, I'm going to set the fence so that I cut off 7.433, or as close as I can get to this number of feet, so I have a nice square, a nice rectangular door. Okay, I hope that all helped out. Again, links below to the original lesson and to the accompanying worksheet, and good luck.